Thank you everyone for joining. This is the LFEDGE TAC meeting for February 11th, 2026. For those who are unaware, EdgeLake is one of the Stage 2 projects here at LFEDGE, and they've recently made some really interesting progress executing machine learning through MCP, and they wanted to demonstrate that today.
So before I get started, I wanted to spend a little bit of time talking about what EdgeLake is and how it is different from other data stores. EdgeLake is essentially a data store that runs at the very edge of a network. So in other words, when I'm connected to industrial computers, industrial controls, literally the edge, that data that's collected from the PLCs and other industrial devices, sensors, etc., stays at the edge. It does not traverse a network. It does not move anywhere. It stays literally next to where the data is being collected. And what ends up happening, instead of moving data, we create a single interface so that you in one spot send a request to retrieve data. We understand where that data is in an environment and then distribute the queries to where the data is. And then the queries come back, only the result sets come back instead of all the raw data. So that's the biggest differentiator of how EdgeLake works versus other data acquisition platforms. So we are doing a trade show next week called Prove It. Prove It is an industrial trade show, and it targets manufacturing and industrial processes. What we're doing is we are taking our EdgeLake product and moving it to Prove It. We have connected an MCP to our environment. So what ends up happening, instead of having to centralize all the data and run your AI requests to it, I literally can leave the data at the edge and literally push the AI request to the data at the edge and have it satisfy the request without having to centralize all that data. In the example, I actually used Claude to generate this diagram. This is actually connecting to our MCP at the edge. I'm connecting to this machine right here. And I asked it to diagram the network topology of the Prove It environment. And you notice there's 3 different nodes. One of the data that we're calling 3 sites. And I'll show you some examples of that in a second. But so we have 3 different machines collecting the same data at each site. So part of data is here. This is site 1, this is site 2, and this is site 3. So when we send a query through the MCP, it goes to this node. This node says, I know data is on all 3 devices, returns that through the MCP, and then it's processed. So I don't have to push all the raw data anywhere. I request through the MCP what I need, and the MCP then pulls using the ANYLOG protocol, pulls the data, the result sets come back and feeds the AI that's requested through the MCP. All right, so what I'm going to do is show you some sample data. This is the data that we're retrieving for the trade show. Here's our 3 sites. You see that there's 6 processes, 1, 2, 3, 4, 5 processes at each site. Okay, so we're pulling data on those 5 processes at each site, completely independent of one another. But when we request the data, it aggregates automatically those requests. And then we're also pulling data from Enterprise C. So this is a pharmaceutical. Oh, by the way, this is a bottling plant, Enterprise B, and Enterprise C is a pharmaceutical plant. So if you could see in Enterprise C, we have chromatography process, we have a titration filter process, and we have a reactor, a bioreactor process. Some of this other data is part of the show and not actually part of the process. The three processes we have is bioreactor, titration filter, and chromatography. And again, these are coming into three separate nodes. So the next thing I did is I ran queries. Let me show an example. This is Claude. Create a real-time dashboard to show the current status needed and operational data for the running of that unit in HTML only. That's the query I ran against the MCP. I then didn't like that, so I add the queries used to generate this dashboard. And then I didn't like that, and I said, and log those calls. So this is the dashboard that I requested. And what we see as a result is the Unit 250 bioreactor. You're seeing critical parameters that are being collected for that bioreactor. You see the batch that's processed, the formula that's being processed, flow controls, the performance and uptime of that process. And then on the right, you see the live queries being executed against the MCP to collect this data. You saw the prompts that I used to generate that dashboard. The MCP, in this case, Claude, the AI, in this case, Claude, connected to the MCP, gathered what's called unified namespace. And unified namespace is a way of describing data in an English way. So raw PLC data comes in with just tags and is not very useful. But one of the things that I did with the MCP is I said, give me a unified namespace for this data. So it looks at the raw tags from the PLC and created the namespace that you saw: chromatography, sensor, type of sensor, and tag. So that UNS is now able to be used, so I can actually tell what process is being run, what batch is being run, what the sensor types are, and what the values obviously are. The other interesting thing about EdgeLake is that it doesn't need any DBAs. So when you connect it to a southbound data source, it will automatically take the raw table data coming in and save it to a table. So what UNS does is when you apply it after you get the raw data coming in without having a DBA to define table structures, it then associates English, or it associates a hierarchy of processes with the raw data table so that you can refer to it in a well-known way without having to worry about where that raw data is stored in the system. Any questions about that?
So, taking a look at this, Mark, first of all, it seems kind of like magic. You hardly told it anything, and it actually created
Exactly.
a
That's
comprehensible
why
dashboard, color coded, easy to understand, surfacing all of the data in real time. Um, so, if I wanted to use this going forward, if I wanted to persist that, what would you do?
this is an HTML file. You just run the HTML file and it connects to the MCP and pulls the data.
So, you wouldn't need Claude once
You
it's
don't need
generated?
Claude. No, let me show
Okay.
you. Here it is. Here's that same dashboard. Enterprise CTFF. Let me find it. Chromatography. Here, well, I don't have it loaded, but here, this is a web browser. You see the actual website here. So here's another dashboard I did. One of the other interesting things, there's a metric in manufacturing called OEE, Operational Equipment Effectiveness. OEE is the kind of like the metric that they use. It measures quality, parts produced, and downtime. So the higher your OEE, the better. We're getting raw data tags from the PLC in this example in Enterprise C. So what I had Claude do is I said, calculate OEE for each process and give me an overall OEE calculation and find issues that is affecting OEE. So I did that in the prompt, and I can actually go and show it to you, but I'd have to find it. I did 40,000 iterations to kind of get what I wanted. This is the final iteration, but effectively that's what I told it. So this is actually what we're seeing here. I told it to give me a refresh rate. I sorted it by shift. I can look at any one of the processes, and it looked at the processes, shows where it is, shows the OEE. Again, I didn't tell it what metrics to collect to calculate OEE. Claude did that for me. So it looks at the three processes and the plant average, and then it found the issues affecting OEE. In this case, you see a column pressure spike, so that affected quality. So it affected OEE by minus 3.2%. I forgot what DO stood for. My brain just went, oxygen. Control loop failure. So this affected volume, the ability to actually get enough product out. So you could actually see exactly the problems that occurred and how it affected OEE in this example. You could see where we are in active batches and how many batches was completed today and where we are in our shift.
So, looking at the quality of what I see here, how much of this is based on how you built the MCP server? And what is the path forward? If you have stats here that you like OEE, would you in the future add the OEE value to the MCP server as a new tool?
That is an interesting question. We did add, so one of the things we did do is we added UNS capability to the MCP. So it'll build what we call policies, data policies that creates the UNS data structure. Claude inferred the data structure, but then we passed that ability to create the data structure inside of the ANYLOG platform or the EdgeLake platform with the additional UNS capabilities we did. Other than that, really all the MCP does is queries to the data. We're not putting OEE in it. It's just querying the data and then letting the AI do all the inferencing. We could put OEE in the MCP. Maybe we do a specific MCP for manufacturing instead of a generic MCP like we have now. There is a challenge to that because a generic MCP would not understand the inference of what are the tags needed to calculate OEE. That's where the LLM comes into place. So I'm not thinking about it, Joe. I'm not sure we could put OEE inside that because we need the LLM to actually process the tag data and understand what tags are necessary to collect the OEE. The MCP is not the right place to do that. It's the place to feed the data to the LLM.
So one other interesting question here is, how long did it take you all to develop the MCP server to this level to be able to do this?
I'm going to defer to Moshe on that answer.
took us a few weeks to do it. But I want to also go back to the previous question that you have, Joe, because it really is something that I think enables all of that. Mark touched it, but just to emphasize it, it's a combination. What works here is combination of two things. One is the ability to reach out to the data wherever it is. So we've got a lot of distributed data, but nevertheless, when the MCP asks something about the data, he could see all the sites. He could see all the data regardless where the data is. The second thing is something that we recently added that fits the MCP, and it's what Mark called the unified namespace. Before being able to bring the MCP to this level of knowledge, there was a preliminary process where we asked Claude to analyze the data and create a unified namespace. And then we translated it to policies that sits on the shared metadata layer. Whether a customer uses the blockchain or a blockchain emulator, there are policies there that describe the relationships. They say, here is a factory. The factory has those sites. The site has this equipment. And now when Mark asks to calculate OEE, he sees two things. He sees all the data, but he also sees the logic, the asset framework. If you are familiar with Aviva Pi, it's called asset framework. He could drill down, and Mark could show you how we could drill down hierarchically using the namespace to reach out to the data. And it's really the combination of the framework, the asset framework, and the data that creates this functionality. So there is here, Mark could show you, we could drill down now, not only using using queries, but we could drill down using the asset framework into the data, which is very much like every historian. But here, the data is not centralized, it's distributed.
Yeah, so in this real world example, I've got a system at site one collecting data only from site one. I've got a system at site two only collecting data from site two, and same at site three. But using the UNS, I can drill into the site, the process, the sub-process, the tank, and then I can look at the data associated with that tank. Okay. What metric, what lot number, etc. And then if you hover, you see in that pop-up the UNS space. I'm sorry, I'm trying to get the pop-up. The UNS space, Enterprise B Site 1 liquid processing tank storage, and then that automatically associated with it with the tables that was automatically generated by EdgeLake when it connected to the southbound data source. So I don't need to worry about this data is in lot number 16. What I need to worry about is show me all the tank 6 data. And it would understand all the tables associated with it and pull the appropriate data. Does that make sense?
Yeah, that's very interesting. And you make it look so easy.
Well, that's what we've been trying to do. We've spent a lot of work over the last few weeks creating the UNS capability because of this very issue. I was going to show one other dashboard. Let me get to it. I was going to show a couple of other dashboards actually. So this is Enterprise B OEE dashboard. You see the overall, you see the 3 sites. Again, this was all automatically created via Claude by just querying the raw data in the tables. You see the processes. Again, I'm showing the query logs. But here's one I wanted to show. Where is it? Here's a very powerful dashboard. So here is the bioreactor. And I said, show me the issues and errors that I got from the bioreactor and correlate them. So what it is, it's refresh now. Let me start the auto refresh. What it's doing, it's looking for PLC issues in the raw data. And it automatically categorizes critical alarms, warning info, and alarms that automatically resolved itself later on when, let's say, the RPMs went down. It shows you the current process. It shows you alarms. And then it literally created active issues and errors acknowledgement alarms so that I could acknowledge them, I could resolve them. All that was done through literally a prompt saying, show me issues and errors and correlate them. And then one other thing I wanted to show is in the real-time world, you have network equipment and you have systems and you have data acquisition systems, et cetera. So one of the things we did for Prove It is I integrated network data along with system data, along with application data. And I said, show me data gap correlation if there's a network error or a systems error. And it literally starts showing how many records are lost and why it was lost.
So, Joe, I think this could go very smoothly into Open Horizon.
Yeah, one of the things I was going to mention specifically, it becomes really obvious when we look at your dashboards here. First and foremost, in Open Horizon, when we are running workloads on hosts, right now, on our own, we don't have the ability to retrieve telemetry data for each working workload. With Edge Lake and that sort of integration, all of a sudden it becomes trivial, especially when we start relying on the Edge Lake MCP server. So one of the things we are looking at doing is exactly that, running Edge Lake along with Open Horizons so that we can collect the appropriate data and surface it. And that will make it much more effective at allowing an administrator to understand exactly what's happening in real time at scale. I can equally envision how powerful it might be to incorporate this sort of functionality with Project Eve and EdgeX Foundry. And that's one of the reasons why we sent the survey out to see if the various projects were already working on their own MCP servers, or if they did not have any plans and if they required any assistance.
Yeah, one thing that I want to point out, if for the other projects, that if you enable it to to service the functionality that you need as a project, at the same time you could now offer the same functionality to customers for their data, because for Edge Lake, it doesn't matter if the data coming in and being analyzed this way is network data or some specific data or data coming from machines, which similar to what Mark was showing here. And the functionality is very comparable to what the legacy historians do. Those are systems that cost hundreds of thousands of dollars a year to maintain. And obviously they need to centralize the data, what is not being done here.
So while we're talking, I'm going to paste a thread, okay, to do a statistical process control chart for the analog data points in Enterprise C, the bioreactor with a trend chart. So you see the prompt that I'm using. This will take a few minutes to generate, so bear with me. But as we're talking, Claude's going to process this, and hopefully by the end of our talk, we'll have exactly what we're seeing here.
So, Mark, quick question. How do we sanity check the results to ensure that the AI is not hallucinating?
Yeah, that's a good question. Unfortunately, that's a manual process. We had to look, that's why I was spitting out the queries.
Mm,
The queries allowed me to see, is it getting the right metrics?
mhm.
Is it doing the right thing? That's exactly why I had these dashboards spit out the queries so that I could check that the right queries were being run against the right metric to give the results that I want.
But also adding to it, we are moving towards automating it. So right now you could enable EdgeLake in a debug mode, and it will show you what requests are coming from the LLM and what's being replied. So that's the starting point. The next phase is if we could take the logs that Mark was showing that were running on the MCP and do a comparison between them, and we could automate that, but we're not there yet. Right now, you can ask EdgeLake to output what was requested and what was replied. So that's the starting point, but it can be automated.
Yeah, unfortunately, I knew how OEE is calculated, and I compared my knowledge of OEE to the data being created. So I saw it was pulling the right data and the math worked out. I did one analysis of one metric and it got the right OEE numbers. So right now validation is kind of manual. That was the whole reason I spit out the queries so I could verify that we're getting the right data to do the value, to do what we needed.
Got it. Thank you.
Any other questions? It's still crunching, so oh, it's getting ready.
Moshi and Mark-san.
Yeah, hey,
This is this is Fukano speaking from the One Friend G. So, question I have about uh, if I understand you correctly, the Edge Lake have stored the data on the distributed each site, and administrator send a query that each distributed data send back to the data respond to the query. So, what is the benefit compare with about centralizing data architectures? Centralized data architecture means about the store data on the one site, for example,
Right.
using a cloud. Yeah.
So if you centralize it, I have to push everything that's collected at whatever
Mm.
frequency rate that you
Hmm.
have to a central site. Everything.
Hmm.
In this
Hmm.
case, I push nothing. I only
Hmm.
get the data when I need it.
Uh-huh.
yeah. So Fukano-san, on the business side, it's huge
Hmm.
cost savings. The second thing
Hmm.
is real time. If you move all the data first to the cloud, real
Hmm.
time is no longer there.
Hmm.
The complexity is huge. You lose ownership of the data, right? If you are an industrial operator, you have to give your data to a third party in the cloud. There are lots and lots of reasons. The
Hmm.
companies move their data to the cloud or to some centralized place, not because it's a great solution, but
Hmm.
because managing the data where it's being created at the edge is complicated. And that's the
Hmm.
problem that we saw.
Yeah,
Uh,
yeah.
uh,
Thank you yeah, I understand. So, could you give me some use cases in the enterprise industries about these distributed data architecture?
Yeah.
What
So
kind of industries
So we
using?
work with some of the largest IT companies now that are interested in what we're doing. And if you
Mm-hmm.
go to a large industrial operator, he will
Mm-hmm.
never move his data to the cloud. Never.
Mm-hmm.
If you're thinking about agentic AI agents that needs to make decisions, think about no lights factory, right? No people there, agents make decisions to shut and open valves. The data needs to be where decisions are being made on the industrial floor. But to do that, your option is to send engineers that would build data platforms on the industrial floor, aggregate the data, unify the data, create tables, create schemas. With Edge Lake, all of that is gone. It's all what Mark showed you from start to end was a completely automated process, zero lines of code.
Let me add to that. The industries that are really targeted for a distributed edge data platform are industries where you have lots of sites and the security issues because I can't move the data to a cloud or bad communications. So examples of those are industrial, oil and gas. Think of distributed drilling well. These are all use cases that we're working with. Mining are in the middle of nowhere, so they're using expensive satellite communications. So I can't really centralize the data. I need to leave the data at the mining site. Windmills or wind turbines, again, they're everywhere. I need to collect the data to analyze it. I can't without it.
Substations.
Electrical distribution and power generation. All of those are perfect use cases for a distributed edge data platform.
And you could go on and go to cars, buses, trucks, ships. I mean, this could be applied to satellites. I mean, look at the price of moving data from a satellite back to Earth. It's an applicable use case.
Yeah, we actually are deployed on ships on large lakes in Europe, and those ships had 3G connectivity, so they could not, and it's monitoring battery information because these are electric boats, and they couldn't push the data fast enough across the 3G connections because they're in the middle of the lake. So we put Edge Lake on there, and Edge Lake is collecting the information from the battery controller, and we're only pulling back what we need from that data to help the captain better use the motors so they don't burn the batteries up and they stop in the middle of the lake.
Actually, the person who designed the solution, Lionel, is on the score. So I don't know if Lionel hears us, but he could explain you more. Lionel, can you hear us?
But yeah, everything that Mark said is correct. That the objective was we were relying on the 4G connectivity, and we had to use the real-time aspect of gathering data as fast as we could, but we didn't get the bandwidth from the 4G connectivity in the middle of the lake. So we rely on the engine that is running locally on the boat to take decision and to push the result of the data to the pilot, to the maintenance people.
Yeah. Thank you, Markson, and Mashi and Yan and Ori. Yeah, I understand about that. Yeah.
All right. I guess I turn it back over to you, Joe.
Great. Thanks a lot, Mark. I appreciate that. And there's so much potential here, especially when I think about even a topic as trivial as monitoring network equipment. Network equipment can generate petabytes of information in a short amount of time, and you need both real-time access to virtually all of the data in order to spot anomalies and respond to them quickly. But at the same time, you then need to take a subset of the data and store that centrally long-term to look for the long-term trends. So it's critical that you, in that particular situation, you have both types of solutions available. So this is really interesting. Thank you very much for presenting.